Basically it's the seismic refit of the BNZ bank, and part of the seismic refit is taking that precast panel down, which is a big component of the structure, and the calculations that they've made that panel has to come down. So basically we're just going to hook the panel on and cut it, and it's gone on the back of a truck and go. Basically came back because we found that the ground out the back wasn't suitable to take the weight of the crane, so we decided to not go there and reevaluate the situation, and came back with a smaller crane and hit it out the front here. This is probably stage 3. Inside we've been doing all of these seismic refits, so there's big steel portals have been put in to basically hold the structure together in case of an earthquake. Obviously what's happened in Christchurch, it's all sort of started to the roll-on effect, and so a lot of the buildings around here are going to have to be brought up to speed. Should be planning to be out of here by the end of the month. If there's anything else that happens, like there's extra bits and pieces that the owner wants to do, so technically it's end of March, early April maybe, just see how it goes. What they found with Christchurch is it was with the earthquakes is that why a lot of the buildings didn't stand up is because it's not only was it doing that, it's doing that, so it's doing 2 or 3 different things at the same time, and it doesn't matter how good your calculations are, until it actually happens you don't know what your building's going to do, and that's the whole reason why it did what it did.
So it was quite good to be there then, for an earthquake.
Yeah, and sometimes it was interesting that some of the new buildings didn't stand up, but some of the older buildings did, and vice versa. So I guess it just depended on where it was at the time of the earthquake, and what the ground was doing. So a lot of the banks and some of the buildings that we're doing is, it's not only the structure that we have to seismically restrain, it's also all of the suspended ceilings now have to have straps, and all of the ducting and everything's got to be seismically strapped, because if you're standing in a building and there's an earthquake, they're not worried about the actual ceiling coming down, it's what's up there that you can't see. So it's all your lights and all your ducting and all of the services that could come down on somebody. And so a lot of that's actually what a lot of the subcontractors now have to do, and it all has to come up to code and producer statements and everything, So the seismic sign-off is actually quite a big component now of the actual building. If you go around New Zealand, a lot of these older towns, most of the buildings should be knocked down and the other issue too is that when you actually start getting into the seismic or upgrading of a building, sometimes it's actually cheaper just to knock the whole thing down and start again. But if you look at the historic value, sometimes it's, if you want to keep the building and keep that character, you've got to decide where you're going to take the hit and bring it up to speed, or you just start again.